Haoran from a few years ago. He's a master's student at Carnegie Mellon University, where I'm a professor, and he got a chance to work. We got a chance to work together on a project called VisLens, which was led by my PhD student at the time, who's now a professor at University of Michigan, Anhang Guo. So maybe this was your start in accessibility. Maybe we'll hear from that. I'll hear from you a little bit about that. And just as a little plug, because I'm really proud that Anhang got this out. If you go to the App Store, you can try VisLens, which is a way to kind of help people with visual impairments use appliances or better kind of get access to spatial information. Anyway, that's not the point of this. I'm really excited to hear about Google Lookout and all the great work that Haoran and people at Google have been doing on this product. So please welcome Haoran. Yeah.
Thank you, Jeff, for the invitation and also all the introduction. And as Jeff said, my name is Haoran, and today I would like to share some of my experience about building an app for blind and low vision people. And this is a little bit about me. So as I said, my name is Haoran, and I grew up in China. I went to Carnegie Mellon University in 2014 for my master's degree. That's where I met with Jeff. And after graduation, I joined Google, and I keep working at Google till now. And since 2019, I have been working full-time on Google accessibility, especially Lookout. So Lookout will be my first topic for today. And especially, I will be deep dive into the challenges and the opportunities we got when develop this app. Then I will talk about our upcoming new feature, image Q&A. And if time permits, we will have our Q&A session in the last. Let's get started. Lookout. So Lookout is an Android app where we aim to use Vision AI and the phone's camera to help blind and low vision people with their daily routine. We initially launched in 2019 with the functionality like reading text, recognizing objects, and we keep increasing new functionality over time. In 2020, we added the new labels mode and the documents mode. And 2021, we included handwriting recognition. And last year, we added the new images mode. And sooner this year, we will launch our new image Q&A, which we collaborated with DeepMind team. And I will talk more about this later. And here is a demo for Lookout. Before I play this, one note is this demo was built on some previous version of Lookout. So if you happen to have the latest version installed, you may see some like naming difference, but the functionality should remain similar. Let's go. Oops.
This is a demo of Lookout by Google, helping people with vision loss explore the world. Here's a user using quick read mode to sort business cards.
Long's Peak, Pub and Tap House, Pub and Tap House. Lindsay better buy 10 drinks, get your 11th one free. Any size, any drink, anywhere. Dutch Bros. The Gypsum Rose Minerals Fossils Jewelry. 303, Furniture, Sunflower Furniture, Mid-Century Modern, American Wood, Danish and Scandinavian Shop Small Saturday, Shop Local, Shop Longmont, Shop Small $10 off.
Now we see the user looking through the history to see all the things Lookout has just spoken. Next, currency mode with a well-framed bill,
US $1 bill,
a folded in half bill,
US $1 bill,
and a bill mostly obscured by the user's hand.
US $10 bill.
Scan document mode helps a user read a book page.
Move device towards bottom left. Move towards bottom left. Bottom left. Move device left. Hold still. Chapter: An unexpected party. Hole in the ground, there lived a hobbit. Not a nasty, dirty, wet hole.
Food label mode reads barcodes and looks up product labels.
Annie's homegrown extra cheesy cheddar bunnies case of product not recognized. Try rotating it to other sides. Libby's pure pumpkin, 15-ounce can.
And explore mode recognizes various objects.
2 bananas. Spoon, scissors, fork.
Lookout also has light level awareness. Here's a user looking for a $20 bill in a dark closet.
Double tap to activate. Low light, flashlight on. US $1 bill, US $10 bill, US $20 bill. Flashlight off.
This has been a demo of Lookout by Google.
Thank you. Not bad, huh? So except for all the functional features in the previous demo, there is one other non-functional feature I want to talk about, which I think is very important to look at, which is on-device. So for all of the functionalities you just see, they happen on-device. On-device means they don't rely on any network connection. You can just run it with Lookout without connecting the network. This has a lot of benefits. For example, it's faster because no RPC, no internet connection, and also it's cheaper. This could be very important for our users who live in some undeveloped country where internet could be very unstable and very expensive. It also provides better privacy. This is also very important to blind people because blind people, they don't always know what exactly in their camera view. So maybe they're thinking I'm just pointing to a water bottle, which is perfectly safe, but his credit card may be somewhere in the background. So to make everything on device, we provide better privacy. But on device also means we have limited resources, limited to the battery, to CPU, which increase the technical complexity when we implement all of this stuff. And I will talk a little bit more about this in the next session. Now is the challenges and opportunities. We face a lot of challenges when develop this app. Some of them we found some solution, but some of them we still don't know what is the best way to solve it. But hopefully, with the help of all of you here and all of you in the video chat, we can solve some of this soon in the near future. And I want to start with reading. So Lookout has two modes on reading. One we call text mode. Text mode is designed for reading some shorter text, like a small paragraph, a business card, something like that. And another one is just called reading now. Is reading some long documents. So user can get a full capture of the whole document, then Lookout can read it. So combine these two modes together, they contribute to more than 50% of Lookout traffic, which means this is the most important feature for our users. But still, there are a lot of issues. First is about framing. Before Lookout can read anything, you have to put the text under the camera view, right? But how would blind people perfectly frame a document? What usually happens is, I observed this from a user study session. So blind people, sometimes they put the camera directly on top of the document they want to recognize. Then they slowly move it up until at some point, Lookout starts to say something. Then they just hear it. Sometimes it works, but sometimes it doesn't. So if there's anything more robust, we can help. And this is our solution. So basically, we integrated a new model, a call detection model, to detect all the edges of the document. And based on the completeness of this code, we can give user some guidance on how to move their camera. You probably already see this in the demo. But when we developed this feature, we had another question is, what is the best way to communicate to the users on how to move their camera? The most intuitive way would be something like move left, move right. That's what we end up doing. But there are still some issues. In one user study session, what we found is the direction to the user is not always the direction to the camera. So when Lookout tells them to move left, they are moving to their left, but their left may be the right to the frame. So in the end, they are moving actually far away from the document. So this is still some really hard a question, really hard to solve. And next part is about layout analysis and reading order. So let's assume we already have a good capture of the document, and we can run OCR to get all the text lines. But we need some way to combine these lines into paragraphs, into pages, and then have an order to read them, right? And one thing we noticed is most of the reading order models, they tend to sort things into columns first, and then read things from top to bottom. this is an example. So for people who couldn't see it, this is like, I think it's an academic paper from some website. And it basically sorted the text into like 4 columns. But with this algorithm, it can get the correct reading order and work perfectly fine. But what if we are reading some form-like material, like a menu or a receipt? If we keep reading that algorithm, what will happen is it will read all the items on the left first, then all the prices on the right, and which makes it really hard to understand this information. So to deal with this, we keep iterating on like training newer like reading order models. Basically, we had a model who can get the more natural reading order of the documents. It works for the academic paper I show in the first slide, and also this like receipt or menu situation. We also make sure like this model can work well when the text is rotated. But still, you can see like in the end of this example, this is still not like 100% perfect, but it's something there. But there is some even more challenging scenario. So in this picture, it's a picture of a magazine. And when you open a magazine, you may notice there is a like very natural curve near the text, like in the middle, because like that's how book works, right? So this photo is probably a good photo you can take for a magazine article. But the problem in it is because of this natural curve, OCR will have a hard time to combine these lines because different words, they have their different angles. And usually how OCR works is OCR will use these angles to determine if they are the same line. But for cases like this, it sometimes will combine like words on different lines together into one line, which makes this information really hard to understand. And this is still an open question, an open challenge we haven't solved yet. Okay, next about product recognition. Product recognition, I think when talking about this, people will initially think of like barcode because it's a very intuitive way to recognize a product. And that's also how we did in Lookup in our like 1.0 version. But we also found some issues with that because, for example, if you close your eyes and I give you a can of beverage, how long do you think you will find the barcode on the can? And I tried it. It usually took me like more than 10 seconds. And sometimes I just couldn't find it because it's somewhere, I don't know, maybe I missed it. So then we were thinking like, can we go beyond the barcode? We don't rely on barcode to make this user experience much better. And here is our solution. So we basically improved our product mode. We created a database of embeddings with the product we can see, the common products. And then in the runtime, we will detect this product and create the embedding and then compare this embedding with our database. We also use this OCR for higher accuracy. And with all of this, we are able to recognize a product within less than 1 second because we don't rely on barcode. But there are still issues with this solution. And the issue is how do we scale? Because as I said, we have a database. But if we keep adding things into this database, eventually this database will grow larger and larger. Eventually, it won't fit on device, right? So probably some solution will be we will just put some common product to this database and leave the others somewhere maybe online to do the online lookup. But then we need to figure out like what do we mean by like common products? Even challenging scenario is how do we get it to work with shelves? Because when people go to any grocery store or like Costco, this picture is what they already see. So if you are standing in the aisle, you will see a lot of product in the view. And how can I recognize any product in this case? We were thinking maybe we can use like hand as an indicator, but still there are some like trade-offs there, and we are still working on this. And last, the object recognition. So I assume like for people who are familiar with machine learning models, you must be familiar with the PR curves. It's like a balance any developer, any like researcher you have to pick between for your model, right? But the case for lookup is a little bit tricky because our users, they are like blind or low vision people. And sometimes they don't always have the ground truth. They can either trust lookup or don't trust it, right? So if we in favor of precision, which means low recall, they will think like lookup is not speaking enough objects. And if we do the other way, they may think, okay, I couldn't trust lookup because it gives me wrong signals. And how can we get a good balance between these two? Another thing is about distance. So for example, like you probably have a keychain like in your pocket, and the object recognition model could usually recognize this keychain within a shorter distance. Shorter, I mean, maybe less than like 0.5 meters. But if you take a step back, make the camera far away from the keychain, eventually your object recognition wouldn't be able to pick it up. How can we solve this for our users? Because if they want to look for this keychain, you couldn't assume them to like look for that within like less than 0.5 meters, right? And we also have some users saying like they want the ability to like recognize their keychain, their own keychain, not any keychain. And it's about instance recognition, and we are like working on it now. Okay, so enough for things that doesn't work well. Now let's talk about things that works. Image Q&A. Starting with image mode, as I mentioned earlier, image mode was something we added last year. And the rationale behind that was that, images are everywhere. But alt text is some some comments for that image that to describe this image for blind and low vision people. But these alt text, they are commonly missing. So in Lookup, we want to enable everyone to experience images, no matter if they are browsing online or on social media or some like images from their friends. Oh, sorry. Yeah, so in images mode, we added 3 functionalities. One is caption. Basically, we will give a short caption of the image. So users will know like, okay, this is maybe a general view of the city. And then we will run object recognition as well as the OCR to get more information. But then our question is, as we all know, like the generative AI is really popular now. How can we make the images mode more helpful with the new generative AI technologies? And here is our solution. So basically, Lookup will generate a much more descriptive caption and to give you a better idea what this image is about. And users can ask their own question by their voice or by typing in a question. And here is a demo.
Okay, Lookout VQA demo. This is a Pixel 2 running on residential Wi-Fi, and we'll be using this photo of a mutt on the beach. There's the ocean in the background, some clouds, and some hills. Let's give it a whirl. So first we're going to share it to Lookout.
In this image I can see a dog is running on the sand. I can also see a ball in its mouth. In the background I can see the water, mountains and the sky.
What breed is the dog?
The dog is a mix.
Does the dog look playful?
Yes, the dog is playful.
Now I can also use this to type in my queries, but I'm going to keep doing voice typing. Describe the ocean.
The ocean is calm and there is a mountain in the background.
Are the waves big?
No, the waves are small.
Let's do 2 more. Are there clouds in the sky?
is a cloud in the sky.
Is the beach busy?
No, the beach is empty.
So, not too bad. Thanks very much.
Not bad, huh?
Okay, look.
Okay, so we also face a lot of challenges when like implementing this feature. And the first thing is about dataset. I assume like people here, you are probably familiar with this dataset. This is a really good dataset for like blind and low vision usage. But we also have to admit, this is a small dataset compared to the like large amount of data we need to train a good like the generative AI model. And for the other dataset we found, there are something like this. So in this example, this is a picture of like a nighttime street, and I can see the traffic lights and some cars in the street. But the alt text says it's a traffic light in the city. That's it, which is correct. Yeah, there is nothing wrong about that. But for blind and low vision people, this information is just too little. They are more interested into a lot of other details. For example, like, is this a city or like a countryside? Like, is there any cars or like how many cars in the street? And like, is it daytime or nighttime? So we don't have all of this information with this data set. So which actually increase our complexity to make a good model. Also, there are some things about the sensitive topics and AI fairness about this generative AI model. So for example, what if user uploads some sensitive image, maybe some image about like porn or violence? Probably we don't want to like talk too much about those images, right? Because they are dangerous. But what if this image is from some news photo about war? It could be violence, but it seems valid because they want to know more about this news, right? Also, there are questions about like sensitive questions and subjective questions. Is this person a criminal? Is this person pretty? How should we respond to these questions? And irrelevant questions, like I can share an image of like a door of this conference room and ask the question, who is the US president? Should we answer it? Should we not? Like, it's a product decision, right? And last, not the least, is person description. Because when you describe a person, it could be sensitive, especially when we're talking about perceived gender. Because in Lookout, it's a very special case. When we are making something wrong, we are like maybe offending people, we are not actually offending our users. We are offending a third party who got recognized in the image. And this is a very tricky situation from like both legal and ethnics. So we have a really good discussion on all of this. And another top why like this perceived gender is like complicated is in most of our data set, our training data, they either say this person is male or female, and it's rarely say we don't know. So after that, with the model will tend to give you like either male or female, but it doesn't say like I don't know, which makes these things even more complicated. And last challenge is about user preference. Because as I mentioned in the like PR curve thing in the object recognition feature, still we see some users, they said they want to more details. And some people says, okay, it's enough for the details, just focusing on the accuracy. And this preference differs a lot between blind and low vision users. Because for blind people, they don't have any idea about the image sometimes. So they want Lookout to be the one to tell them like, what's this about? And there are some users, they even say like, okay, so if you really have a good model, what should happen is I should get enough information from caption. And I don't need to ask any question by myself because they should be already there. But for low vision people, they probably already have some idea of the image, right? They may be more interested into some details. So they can ask their own question about this, like what pattern is the clothing, something like that. So all of this is really hard like product decisions when you actually want to make it happen in a product. So here is my personal learning after like 4 years working full-time on Lookup. There is usually a gap between the technology we have and the actual useful product BLV people needs. For example, OCR has been there for more than 40 years, but still now BLV people have a hard time in reading. And it's usually easy to get something done by 80%, but extremely hard to get the other 20% done. So let's try closing the gap. And yeah, that's it. That's all of my presentation. And thank you for being here. And I will be happy to take some questions if you have. Right.
Can I ask a quick question? Yeah, come up to the mic, please, if you can.
Yeah, sure.
Awesome. Thank you for your talk. Really cool work that y'all are doing. So from what I understand, there's different modes for like reading or like recognition, stuff like that. Has there been any interest in other users or your team looking to unify all these modes into just a single interface?
That's a great question. So let me repeat that. The question is, have we considered to combine like these different functionalities into one mode rather than keep them into separate mode? Yes, we did. But it's complicated because for different modes, it runs different models. And also remember, I mentioned like one of the key features of Lookup is on device. So we want to run things on device. But if we have one mode which runs maybe 10 models, it won't fit on device, right? And it's going to take really a long time. And also from user experience perspective, like when should we announce what? Like in this photo, it's probably have both text and objects and people and whatever, so many things. And what is the most important things for our users we should announce? There are like just hard questions. We don't have a good answer yet. So right now we are still keeping them into like independent modes.
Thank you.
Sure, thanks.
And so I wanted to ask you about the difference between working like the user having their camera on and taking photos of the world or video versus receiving photos via text or seeing them online. Is there a difference between what kind of caption we want to produce in these two cases? And is it really only the seconds that we would want to generate a caption?
Yeah, that's a good question. So so when we initially designed Lookup, we were focusing on the like live modes. Basically, we were using like the video stream as input because we want to help users with something like in their surrounding, like to read this letter in front of me or like recognize this object in front of me. We didn't think too much about the images sent from elsewhere. But after like 2 years, like after we launched our product, we keep getting like requests from our users, like they want this functionality. So that's why we added images mode. As I said, it's added last year, right? And only after that, we started thinking like, how can we make this more helpful? Because this is like a separate use case other than the live camera use case. And that's also why we are adding like this image Q&A feature, and it's gonna be released soon. Yeah, I hope I answered your question. But
yeah, absolutely. And just a quick follow-up: do you feel like datasets like this with the image captioning part of the dataset and others are more useful for? Are they like specifically designed for that kind of use, the image mode that you're now developing, or is there more types of data that we need to be collecting for that kind of use?
yeah, that's a good question. So the question is about the data set we are using for training this image and Q&A mode. So as I said, we are collaborating with DeepMind team. So DeepMind, they are mainly focusing on training this model. But from my perspective, from what I know is, with this, that is the most important data set for this use case, because there are just more details. And that's exactly what BLV people need. And they also use some other data set, something like text. I don't know the actual name, but they do use some of them. But they have to do some special tuning for the models for those data sets to make sure they can like meet our needs. So yes and no to your answer.
One last question.
Okay.
That's a great, was a great talk. Patient ceremony was very interesting. Did you find a specific situation where your image training model did perform very good or very bad in a specific situation? Like, for example, like when we don't recognize the traffic lights, it may perform very bad because they're very small in the image. But if you want to recognize something in your hand, it may perform very good because they have visual data. So, like, do you find those kind of situation, interesting situation, but good one?
Yeah, that's a good question. So basically the question is about, is there any special scenario like our model, we don't perform very good? So yes, but I don't have like numbers on those. But one thing is about like text in the image. I don't know if you know much about OCR, but for OCR to perform well, this it has a like minimum resolution of the image. It has to be like big enough for OCR to recognize small text. But for like image Q&A, when we send the image to the server, they usually compress the image and make it them small to make sure that it won't be too big for the network traffic, right? So which also means it sacrificed the text questions because it couldn't recognize all the text on the image. So that's definitely one thing. Like I don't think that the current model are doing really good. Okay.
Thank you so much.
Yeah, cool. Yeah, thank you everyone. Yeah, I will.
Again.
Cool.